In this video, we're going to go over quadratic inequalities. The solutions to quadratic inequalities are written as intervals. An interval is the set of all real numbers between two given numbers. The two numbers on the ends are the x-intercepts. The endpoints might or might not be included in the interval depending on whether the interval is equal to or not equal. What that means is when you graph the endpoints as an open dot, the original inequality means that they're not equal to it. If you graph it with a closed dot, the inequality states that it was equal to those points. Recall that multiplying or dividing both sides of an inequality by a negative value or number requires flipping the inequality sign. For the first round through the examples, I'm just going to use the quadratic formula on all of them. Then I'll go through and I'll show you how to factor if you want to factor it to go faster. So this would be a, b, c. X is equal to negative b plus or minus the square root, b squared minus 4ac all over 2a. You can shortcut this in your head and go straight to a positive 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 18. 81 over 2, 3 plus or minus 9 over 2. 3 plus 9 is 12 over 2, which equals 6. 3 minus 9 is negative 6 over 2, which is equal to negative 3. These are solved for x. I'm going to place them on a number line. Negative 3, positive 6. I check my inequality. Because it's equal to, they will be closed dots. And then I'm going to test a value to see where I shade. So I'm going to test the number 0 by plugging it in. When I plug this in, I get negative 18 is less than or equal to 0. That is true. So I'm going to shade where that value is. To write my interval, it'll be from negative 3 to 6. Because they are closed dots, we have the bracket. If, let's say that the inequality was facing the opposite direction to start with. When I go through and do the formula, all of my numbers are the same. I would still get out a 6 and a negative 3 for my solutions when I plug in a, b, and c. Put them on the number line. I'm going to do closed dots. If I plug in a 0 to test, I'm going to get 0 squared minus 3 times 0. When I enter that into my calculator, I get negative 18 is greater than or equal to 0. Negative 18 is not greater than 0. So this would be a no. That means I do not shade the center. I would instead shade the outsides, which would be negative infinity until it hits negative 3, and because it's a closed dot, This is the only time we have to worry about what we're using. It'll be a parenthesis unless it's a closed dot, then we use the bracket. There's a gap. Then I go from 6 to positive infinity. So that would be your interval notation if the inequality had faced the other direction. Example 2. A, B, C. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a plus or minus the square root of, I enter it in, oh, it's a 15. That gives us 4. The square root of 4 is 2. 8 plus 2 is 10 over 2, which gives us 5. 8, 7, 6 over 2 would give us a 3. I plug those onto my number line. Positive 3, positive 5. My dots will be open. Now I need to test. So when I test, I'm going to check the middle. My testing value, I'm going to pick the number between 3 and 5. I'm just going to test 4. So when I plug it in, I would get -1 is greater than 0. -1 is not, that's false. -1 greater than 0. No, which means I shade the outside, and I would write my interval as -infinity to 3. Because it's an open dot, I'm just going to use a parenthesis. There's a gap, 5 to positive infinity for interval notation. Example 3, my information is not all on one side. So I'm going to add the x squared over. I'm going to minus the 8. That will cancel those out and give us x squared positive 4x minus 9. Now I have my a, b, and c. Negative b plus or minus the square root b squared minus 4ac all over 2a. -4 plus or minus square root of 4 squared minus 4 times 1 times -9 is 52 over 2. The square root of 52 is going to be a decimal. I'm just going to round it to 7.2. When I combine them, I do -4 plus 7.2, and I do -4 minus 7.2 for my two answers. -4 plus 7.2, enter, divide by 2. -4 minus 7.2, enter, divide by 2, enter. These are the numbers that go on my number line. -5.6, 1.6. The dot is going to be open. And then I'm going to test a number in the middle, and I like 0. 0 is always easy to plug in. 0 squared plus 4 times 0 minus 9. When I plug that in, we get negative 9 is greater than 0. That's not true. So I would shade the outside. Negative infinity to negative 5.6. It's an open dot, so I don't have to worry about my parentheses at all. 1.6 to positive infinity. I'm going to do the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. When I enter this in, it'll give me a negative 20 over 6. This means that it is imaginary, and there are no x-intercepts that are on the real number line. So I would have no numbers on here. I would just test. I'm just going to test the number 0 and see if it's true or false. So 3 times 0 squared. When I plug that in, I'll get a positive 2 is less than 0. 2 less than 0, that's not true, that's no. That doesn't work. So there would be no solution. Just like I did on the other problem, if I had a different inequality sign and it said that it was greater than 0, so I have this equation to start with, I do the quadratic formula, I would still get negative 2 plus or minus the square root of negative 20 over 6. Because it is imaginary, there are no values on my number line, so I would plug in a 0 to test. When I plug that in, we get that 2 is greater than 0. That is true, so there would be infinite solutions. Or you can say that it's negative infinity to positive infinity. Because it's true, I would end up shading the whole piece. Whereas down here, where none of it was true, I wouldn't shade any of it. If you want to factor on the videos to make it a little bit faster, you can always factor the quadratic. Put x and x. Multiples of 18 would be 3 times 6. 3 minus 6 would add up to negative 3. These would be my two values. Negative 3 and 6 are the two values I place on my line. So on example 2, if I wanted to shortcut and just factor it, I would get x and x. 15 would be 3 times 5. They would both be negatives to get negative 8 when you add them up. X equals a positive 3, x equals a positive 5 when you solve it. And that is why we have 3 and 5 on our number line if you want to do that factoring instead. It's a little bit faster.